Hey everyone, this is Mohammed Nadeem and welcome to my YouTube channel. Until here, we discussed about the physical quantities and the types of the physical quantities and the basis of magnitudes and direction. So here, on the basis of magnitude, we classified that into base physical quantities and derived physical quantities. And on the basis of direction, we divide the physical quantities into scalars and vector physical quantities. So here we don't discuss the sphere or the circle. So what about the geometrical physical quantities? So in this video we will discuss about the purely geometrical physical quantities, and that purely geometrical physical quantities are called the supplementary physical quantities. So here this supplementary physical quantities are divided into plane angle and the solid angles. So the plane here, the name indicate that plane is actually concerned with the 2D. So here this is the plane angles mean we will discuss the angle in the 2D. Mean the here we will discuss the angle in 2D, and the 2D is actually the circle. So here we will discuss on the measurement of the angle which is made inside the circle. So here is the plane angle and this is the solid angle. Solid angle is actually the angle which is made in 3D. So even such like in sphere. So in this geometrical physical quantity, we will discuss about the sphere and how to measure the angle in the sphere. So here this plane angles have units, and that units the unit of the plane angle is the degree and the radian, and the unit of the solid angle is steradian. So in this video we will discuss about the degree, the radian, which are the units of the plane angles, and also at last we will discuss about the steradian, which is the unit of the solid angle. So here this is the 3D and these two are the 2D, mean that this is concerned with the circle, and here this 3D is concerned with the sphere. So we will discuss all these the circle, degree, radian and steradian in the form of simulations. In the previous classes you may draw the angles just like this. So this is actually the triangle, and we know that we have 90 angle here, and this is less than the 90. Let's say this is about 25 degree. So in this lecture, in this portion of the lecture, we will discuss that what does mean by this degree here. What does mean by this 90 degree here? So the degree is nothing but this is the classification or the division of this whole circuit into 360 parts. So here we have the 0, and then we will take steps. So here if we take about 360 steps on the circle, and after taking 360 steps, and then again we reach here to the original position. So if we take 360 steps in the circle, so here each step must will form some angle with this center. So here this is the center. So for the first step, I can write here is that, let's say this is the first step, and here this is the initial point of the first step, and this is the uh, end point of the first step. So if I connect these initial and final points of the first step, then it will make some angle theta with the center. So here it will make some angle theta. So that theta will be equal to 1 degree here. because we convert the whole circle into 360 parts, and each part is called 1 degree. So here, let's say if we consider this part, so let's say this, in this part, this is the initial position, and we join that with the center. So this is the initial position, and this is the final position. Sorry for my bad handwriting. So here it will make some angle theta, and that angle theta for this step, this angle theta for this step will be equal to 1 degree. So similarly, for each step, we will count 1 degree, 1 degree, and 1 degree, and therefore the whole steps are 360, 360 steps. So therefore, we will say that if we add all the angle of these all 360 steps, it will give us the 360 degree. So here, let's say this is the direction of the arrow is 0 degree. And if I take one step here, let's say I'm going to take one step here. So if I take one step here, then from the 0 to this one part of this circle, it will make some theta angle, and that is called 1 degree. So by taking the second step, it will make the 2 degree with respect to this original position. And here, if I take each step, it will make some theta with this center here. So this is the center of the circle. So this was the initial position, and up to this position, we take 18 steps. So from the angle made with this initial position and this final position will make some angle theta, and here we take 18 steps, therefore this angle theta is 18 degree. And if we take further steps, so it for each steps it count 1 degree. So here if I take let's say 45 degree, then the with respect to this original position, it has taken 45 steps, and for each steps we count 1 degree, so therefore it is called 45 degrees. So the person here in the position of 45 degree from the ground. And similarly, if we take similar up to 90 degrees, so here it's going toward the 90 degree. So if it reached 90 degrees, so the angle made with its original position is here, is this 90, mean that we take 90 steps, and for each step we count 1 degree. So therefore this is called 90 degree. If someone asks you that what is the angle made here in degree, so the angle here is actually if we make the circle around this this is the one part of that circle, and the total circle is divided into 360 parts, so 360 degree, and this is the one part of that whole circle. So we will divide that by 4, it is equal to 90 degree. So here this will be 90 degree. So the same case is here. So if it make the triangle here with the original, sorry, uh, here with the original, so the angle made at this position is here is 90, mean that we taken 90 steps when reached to here in the circle. So the whole circle is 360, and we cover the one part of that circle. So the one part of that circle is count to be 90 degree. If we reach here to 180 degree, and similarly if we increase this steps, and then we will reach to here one here 270, and in this case this 270 mean that from the original position we take 270 steps in order to reach here to 270, and the theta made with this original position is actually the angle made with that original position is 270 here. And here, if we reach to, let's say, uh, I'm going to reach it to 360. So this is the 360. So if we take 360 parts, if we take 360 steps in this circle, then we will reach to its original position. So from here, we conclude that if we convert the whole circuit into 360 parts, and for each part, there must be some original position and the final position. So let's say this is the one part, this is the original position, and this is the final position. In this case, this original, if we combine the original position and the final position with the center, so in the center, it will make some theta. So here that theta will be that theta will be 1 degree here. So we convert these two this whole circle into 360 parts, and each part make 1 degree. So therefore, this whole circle is whole circle is making 360 degree. So for each step, we write 1 degree, and for 360 steps, the degrees will be 360. This is called the plane angle, because this circle is actually the 2D. The x is it is made for the y-axis and the x-axis. So this circle is the 2D. Therefore, we call the degree as the plane angle. And in plane angle, we work with the 2D. Now we will discuss about the radian. So what does mean by the 1 radian? So now what does mean by the 1 radian? So until here you know about the degree. So if someone asks you that what does mean by 1 degree, so you will say that for each step, the initial and final position will make some angle theta with the original. So for that single step, the angle made here with the center is called the 1 degree. But here we don't know about the radian. So this is actually the circle, and the circle have radius r. So this is the radius from this center to this arc. So this is the radius, and this radius will have some lengths. So let's say take this as a 1 centimeter. So let's say we have the 1 centimeter radius circle, and if we take the arc, mean the surface of this circle is 1 centimeter. So here the radius is 1 centimeter, and if we take the 1 centimeter part of this circle, okay, here this is 1 centimeter, and this part of this circle also 1 centimeter here. This part of this circle is also 1 centimeter here. So in this case, with this original radius, if we take that same magnitude of the part of the circle, and then we will reach here. So with this original position and this final position, sorry, this is the final position, there will be some angle made with the center. So here will be some theta, and this theta is called 1 radian. So 1 radian is actually, if we take the the radius time parts from the circle. So this is the radius time parts, mean that the radius here is 1 centimeter and this part is also 1 centimeter. So with that original position and that final position, it will make some theta, and that theta is called 1 radian. So here this about the 1 radian. So what about the 2 radians? For the 2 radian, it means that the radius of the circle is 1 centimeter. Then we will take 2 times of the radius. So here 1 time of the radius is 1 centimeter and the 2 time of the radius is the 2 centimeter. Okay. So here, if we take the 2 centimeter arc of the circle, and this is the original position of that arc, and this is the final position of that arc. This original position, if we connect that with the center, and this final position also connect with that center, so it will make some angle theta with the original position. So let's say this is the original and this is the final position. So in this case, the angle theta made is 2 radian. For 1 radian, this arc is 1 centimeter. For 2 radian, this will 2 centimeter. For 3 radian, this will be 3 centimeter. So here for the 3 radian, let's say I'm going to select the 3 radian. So the 3 radian is this. So in this case, the same circle, okay, we have the circle having radius r, and r is equal to 1 centimeter. So for 1 radian, we will take 1 centimeter. For 2 radian, we will take the 2 centimeter. For the 3 radian, we will take the 3 centimeter arc of this circle. So if we take 3 centimeter arc, we will reach here. So with the original position, so this is the original position, we will connect that original position with the center and also the final position with the center. So here will be angle made. So the angle will be this. Now this theta is equal to 3 radian. 3 radian. You may hear about that pi is equal to 3.14. What does it mean? This is actually the radian. So here I'm going to show that here this is the value of the pi, which is equal to 3.14. If I select this, then it means that we take 3.14 radian. So it means that we take 1.45 radian. So for 1 radian, we will take 1 centimeter. For 2 radian, we will take the 2 centimeter because the radius of this circle is 1 centimeter. And for 3 centimeter, we will take 3 centimeters. So from this original position, we take 3 centimeter. Then we will take 3.1. So 3.1, it let's say is this, and then 3.14 is this. So this is actually the pi. This is called the pi, and pi is actually 3.14 radian. So here radian is actually the this is the original position. Here I'm going to change the color. This is the original position. Okay, and then we take the 3.14 magnitude of the radius, then we reach here. So we will connect this final position and this original position, and in this case some angle will be made here from the original to final position. In this case, this theta angle is equal to 3.14 radian. So if we cover 3.14 radian, then it will cover the half of the circle. So here the half of the circle is shaded. So for 1 pi is equal to 3.14 radian, and which is equal to the half of the circle. So the 1 pi cover the half of the circle, then 2 pi will cover the whole circle. So I'm going to select this. Now the whole circle has covered. So here this if we take theta is equal to 2 pi, then whole circle will be covered. So this is actually 2. The pi value is 3.14 and it is equal to 6.28 radian. So if we take 6.28 radian of the circle, then it will cover the whole circle. For one whole circle, there will be 2 pi radian. There will be 2 pi radian. So this is for the whole circle. And similarly, for the one circle, in previous case, for the one circle, there was 360 degrees. Okay, for the previous case, for one circle there was 360 degrees, and now for the one circle there are 6.28 radian. Okay, here on the this is in case of the degree, and similarly for the radian, one circle is equal to 6.28 radian. So from here we can find the relationship between the radian and what we can say degree. So here one circle is equal to 360 degree. Okay, one circle is equal to 360 degree, and that one circle is also equal to 6.28 radian. So from here we can find the relationship between the degree and the radian, and which is given by this. Here 360 degree is equal to 6.28 radian. Okay, here in order to find 1 radian, we will divide this by 6.28, and similarly here 6.28. This 6.28 will cut with that 6.28, then it will give us the final value is. So here 1 radian will remain. So here 1 radian is equal to this 360 divided by 6.28 will be equal to 57 degree. This will be equal to 57 degree. So it means that 1 radian is equal to 57 degree. So what I'm going to say here is that this whole circle is converted into 360 degree, and here this 1 radian cover some part of the circle. So this 1 radian cover from here it cover 57 degrees. So it covers the 57 steps out of 360 steps. So 1 radian actually cover the 57 steps, mean that 1 radian is equal to 57 degree. Okay, this was the this radian is also called the plane angle because it is defined with the circle, and the degree is also called the plane angle, and these two degree and the radian is called the plane angle. So this is actually we have this pair, and this from these parameters we know that this radius of this pair in this case is 1. And here the solid angle, solid angle mean that the steradian we consider to be a 1. So the one steradian is actually, if we take, let's say I'm going to take, so here we have, this is actually the center of the sphere, and to the outer surface. So here to the outer surface there will be some distance, so this is the distance towards the outer surface, and we know that this distance is called the radius. Okay, this will have some value. So let's say this have the 2 centimeter. This radius is 2 centimeter. So in order to find, to know that what is how many is the one steradian, then for that we will take some area. So area is equal to length multiply width. So the unit of the length is meter and the unit of the width is also meter. So here we know that the area is meters in meter square. Okay, so by taking the same analogy, we can find the area of the surface from this radius is. Area of the surface in this case is equal to, let's say, radius multiply radius, because one radius is measured in meter, the other one is also measured in meter. They two when multiply it give us the meter square, and that is the unit of the area. So here let's say we have 2 centimeter here, so this will be called this 2 centimeter multiply 2 centimeter. Okay, this r and r mean that 2 centimeter multiply 2 centimeter, and it give us the 4 centimeter square. So this for this centimeter square is the unit of the area. So therefore here we will take this area on the surface of the sphere. So here this sphere will have the surface, so this is the surface of the sphere, and we take this area. So this area, okay, uh, okay, this is the area on the surface of the sphere, and the magnitude of this area is 4 centimeter square. So this area will have some magnitude, and the magnitude of that area is 4 centimeter square. If the radius of this sphere is 2 centimeter, okay, if this radius is 2 centimeter, then we multiply that radius 2 times, then it will give us this area of the sphere. So here let's this is the area of this sphere. Okay, this is actually the area of this sphere. Okay, and which make a cone like shape here with the radius. So this cone will have some 3D angle at the center. Okay, this will have some 3D angle at the center here. So in this case, this 3D angle is called the steradian, and the one steradian is actually the if we take if we multiply the radius 2 times. Okay, if we multiply the radius 2 times, and it will give us this area. In this case, it gives us this area, and due to which some 3D angle will be formed at the center, and that angle in this case is called the one steradian. So here we select the 2.42 steradian instead of one steradian. So in this case, it means that this original area will be taken 2.42 times. So this is the 4 centimeter, and the 2 times of this area will be 8 centimeter square. So this will be 8 centimeter square. So now this selected area has changed to 8 centimeter square. from the 2 centimeter from the 4 centimeter square. So in this case, it will also made some angle with the center here. So it also made some 3D angle at the center. So in this case, that angle is called the is 2.32 steradian. So that angle is called the 2.32 steradian. So it may seem complex, like, but this is very simple because first we will take the radius of the circle and we will multiply that radius. It will give the area of the circle. Sorry, it will give the area, and we will take that much area from the surface of the sphere. Okay, and that much area, the boundary of that much area here in the palm of the cone will make some angle theta with the center. And in that case, that angle is called the 1 steradian. For one circle, we have 360 degree. Okay. For one circle, we have what we can say 2 pi radian. Okay. Now, for one sphere, how many steradian will be there? For one sphere, how many steradian will be there? It means that for finding that we will use the mathematical formula theta, which is so in this case the steradian is actually represented by this sigma like shape. So this sigma is equal to the overall surface, the surface of the sphere. So the surface of a sphere in this case divided by r square, pi r square, and divided by this r square. This r square will be cancelled, which is equal to 4 pi steradian SR, 4 pi steradian. So for one sphere, okay, here for one sphere, the number of steradian will be 4 pi, 4 pi steradian. Okay, this is for one, sorry, and this is for one sphere. In one sphere, 4 pi steradian is present. In one circle, 2 pi radian is present. In one circle, 360 degree is present. So this was the detailed overview of the supplementary unit. So the supplementary unit is actually the pure geometrical physical quantities. So here we will deal only with the theta, the angles. Therefore, it is called the pure geometrical physical quantities. And according to the System International, they give them a name called supplementary quantities, and we classify that into plane angle. The plane angle is 2D. I mean they are 2D, and circle. Okay, here it cover the degree and the radian because they are concerned with the circle. And similarly, this is the solid angle, and solid angle is 3D, and this is valid for the sphere. And the unit of that is called the steradian. So that's about today's lecture. That's it, guys. Thanks for watching.